Welcome to Backyard Wellness, the show that tries to bring you healthy options from the region, community, and even your own backyard. And today the show is part of a series on regenerative agriculture and permaculture. So I have with me today Dr. Bruno Bosari. Dr. Bruno Bosari is a professor from Winona State, has studied across the states, even Louisiana, and he was born and raised in Italy in a town near Bologna, where his dad was a sharecropper. So he's come a long way, and now he talks about pollinators, soil health, and regenerative farming, and is working with Southeast Technical College on a curriculum for regenerative farming. So I'm honored, and it's a pleasure to have with me today Dr. Bruno Bosari. Welcome, Bruno.
Thank you. Thank you for having me.
You're welcome. I'm looking forward to this. We're going to talk about dirt and soil.
We're going to talk about soil.
Soil,
okay?
not
Soil.
just dirt.
It's
Huh?
not dirt, absolutely. Dirt is soil out of place.
Oh.
Okay?
Oh.
Soil is a very complex ecosystem,
Oh.
as I will try to demonstrate. And the idea that now professionals in the field are trying to employ to educate farmers and landowners and gardeners to be better stewards of their soil is through this conception of soil health,
Okay.
which embraces the soil characteristics from the physical, the chemical, but now even more finally the biological and ecological point of view.
Oh.
So soils are really complex systems.
So it's not just a place to just put your plants in and pretend everything will be well.
Absolutely
I mean,
not.
I've seen one place where the soil, the corn was not growing very well, and across the street the corn was growing very well. For whatever reason it was, I don't know if they really knew about the soil.
Right. With farming, we basically try to take control over the management of the soil for an economic crop that we are interested in growing, right?
Mm-hmm. Mm-hmm.
But we finally begin to understand a little bit better that to be successful in growing that economic crop, the farmer, besides the typical inputs that are necessary to lead the crop to a certain yield, there are also certain characteristics that the soil possess that the farmer needs to know about, because by employing or relying on those attributes, then number one, there may not be the need to employ those off-farm inputs as much as they are employed. And number two, that knowledge may help the farmer to protect that soil from erosion, from loss, and by doing so, maintaining the productivity of the farm and making that agriculture, rather than extractive, more regenerative, more ecological.
Well, this sounds very complex.
It is, but again, not even the biggest specialists would tell you that they know it all, okay? Especially when it comes now to understand all the synergies that are happening within that ecosystem that we call now soil ecosystem. For example, here I have, a soil aggregate from two different samples. And so just by looking at them, okay, they feel different to the touch. This one on my left feels more gritty, okay? So I can already make some simple observations that allow me to see their aggregates. This one on my left again has roots, and probably the one on the right also had roots. But if I break that pad, I can get a better feeling. Now my fingers now from the pad on the right are now I have very small soil particles. So that is to say that every kind of soil comes from mineral particles that derive from the breaking down of the mother rock. And these are sand. So we have different kind of sands, the largest particle, medium size, small size, and then we have silt. Silt would feel to the touch like wheat flour, like talc, for example. Then there is a third component that comes from the breaking down of rocks and mineral, and this is the clay. So clay are extremely small, absolutely microscopic, but they are very important for all things concerned with the chemistry that happens within a soil. So the uptake of that nitrogen, phosphorus, potassium, and other nutrients, and then when the root passes by, the release of those nutrients and uptake of the nutrients by the plant happen because of the clay content. But at the same time, a soil that has a high level, a high percentage of clay is what becomes a heavy soil. It's a soil where water percolates very slowly. It's a soil like, for example, you would find good soil like this one being a rice field where water needs to be retained, right? Because rice likes it wet, likes it waterlogged all the time. But definitely a heavy soil may not be conducive to the growth of, for example, of crops like peanuts or potatoes or a root crop. Okay?
Is that like volcanic ash then?
No, this is just clay.
Clay,
Clay, okay, so clay. On the other hand, a soil that has too much sand is a sandy soil. So it's a soil that is very loose. I live in Winona, and so probably that is the type of soil that I have. Okay? So what does happen when soil interacts with water and its texture is too sandy? That water percolates very quickly. So I may have to have a need to irrigate my crops because that water is not retained very well. So like in all things, you know, in the middle stays the best. And so what I call a loam soil is a type of soil that has a good blend of silt and sand and clay too, all right? And then a loam soil would be ideal then for agricultural purposes with some variation, as you could see, like you will from that textural triangle that agronomists use, soil scientists use to measure the soil texture. So this idea of soil health, like I said, combines chemical, physical, and biological characteristics.
Wow.
And the biology that goes on in soils takes place because of the millions and millions of microorganisms. Primarily, I'm talking here about microscopic fungi, I'm talking about mycorrhizae, I'm talking about bacteria. So the biological activity that is happening in the soil is vital for the decomposition of crop residues, for the decomposition of anything that falls in the ground. So I would see, you know, if we could see underground a little bit, and if we could enlarge those biochemical processes that happen primarily by soil microorganisms, the soil, especially its top, becomes like a big digester. And so it's beautiful. I like the quote, you know, from the writer of, anyway.
Waldo?
No, it's a quote that talks about the soil, like waste. This quote says is a human concept, but nothing is wasted in nature because everything is part of a continuous cycle. Okay, so this is a very important quote to me that already in the 1800s made somebody reflect on or look at soils as most have never been able to look at. And now that we know about all the biology that happens within the soils, we certainly understand that in nature nothing gets wasted. So on the farm we may do composting, okay? And many farmers know about the value of compost. In the forest, in the prairie, the recycle of the decaying plant population is basically regenerating that fertility that we humans have been replacing for the last 200 years with chemical fertilizers.
We'll probably show some pictures from Polyphasis because that's how he's building up his farm. by incorporating the different kinds of agriculture and to build up his land and everything. So we'll have a few segments shown on that too.
Yes, and I think Joe Salatin of Polyface Farm
Right.
is a pioneer that for many, many years has been embracing this more ecological type of farming, and now after, I don't know, 4 or 5 decades, Polyface Farms is really a demonstration farm for many other agriculturalists who wants to see what are the benefits of increasing the diversity, not only of crops in what we would call a crop rotation, but also employing farm animals. So the grazers at Polyface, there are sheep, there are cows, you know, with their grazing, they contribute tremendously to amplifying the effects of biological activities in the soil by enriching the soil in microorganisms that further decompose anything that falls on it, for the benefit then of agronomic crops that are going to be cultivated throughout the cycle of growth. So very important, you know, to understand this, and I brought few items here also to demonstrate this. So here in my jar I have my garden soil sample that I have ground in small particles to break all its structure. Okay. Now if I take a little spoonful of that soil and I put it on a little dish, I want to show you what happens when I'm exposing that little teaspoon of soil to just a milliliter of hydrogen peroxide. Okay?
Oh, watch out.
So basically what is going to happen, and I don't know if the cameraman will be able to show you this, but maybe Lois, you will be able to show this. There is some effervescence happening.
It's fizzing.
Okay? So what's happening? Those little bubbles are basically showing that my little sample of soil is rich in aerobic bacteria. And aerobic bacteria convert that H2O2, the hydrogen peroxide, in water, okay, that is humidifying the sample, and oxygen. Okay? They have a little enzyme, those bacteria, that make that reaction possible. So this is just to give you an idea that as I'm walking around the garden, I'm walking around the farm, if I want to have a qualitative idea of whether or not my land has aerobic bacteria, I can do this little test. Okay? I could compare then, I cannot quantify, I cannot tell you how many bacteria are in this sample. But if, for example, I tested now my garden soil, and I want to test it now with this other different soil, maybe from an adjacent field, maybe from a different farm, I can do the same test again. And so here we go. I'm going to apply approximately another milliliter of
Peroxide?
of hydrogen peroxide, and look at the bubbles. And here, let's say on a scale of 0 to 10, what score would you have given to the garden soil? What score would you give to this new sample?
Well, the first one would have a 10, but this second one is barely doing it. Maybe it's got a 2.
Okay, so you see on a scale from 0 to 10, you could qualitatively, approximately, with a big approximation,
Sure.
could say there are definitely many more bacteria in Bruno's garden soil.
It's beginning to do something. So
Okay.
maybe it's cooking enough that it's going to a
Maybe.
2 or
Yes.
2.5.
So again, yeah, wait.
But it was much
maybe,
slower.
Wait maybe 2-3 minutes.
Maybe,
Okay.
because it's beginning to work.
So would you give it now a higher score?
Yeah, it's cooking.
Okay.
Yeah,
So let's say
it's
maybe
puffing up.
maybe 4.
Yeah, it's going there.
Okay.
Who knows where it'll go at this rate?
But definitely, would
You
you?
see, it's made a difference. I mean, it was just a few little crumbs, and now it's
Right.
puffing up.
When we talk about soil health, then the farmer, the grower, the gardener should also reflect on what can I do to minimize tilling? Okay, because every time I plow, every time I till the soil, and every time that I lose organic matter from that topsoil. So the carbon that the aerobic bacteria are using as a food for them to thrive, multiply, and with their chemistry to break down anything that falls on the ground into the nutrients that plant roots will uptake, I'm basically counteracting their activities when I till too often, when I plow too often, when I disc the fields too often. Okay? So learning about soil health makes us also reflect on, do I really need to get on the tractor today and till the soil? Okay? Cover crops is a good alternative because the growth of roots of plants that may not be economically valuable, let's say, but they are ecologically extremely valuable because, for example, you plant root crops as cover crops, like radish. Imagine that big daikon radish. That big root, taproot, will expand, will break the soil, will increase the porosity of the soil, and that will make that soil retain water and moisture more effectively. That will invite that moisture, more microorganisms to be part of that complex system. And altogether, you know, in those voids, oxygen also will be retained more effectively. And so the soil becomes friable. The soil becomes, by its alone, just by several years of these sustainable farming practices.
Well, some people talk about, I think it is forest gardens, where they combine plants that will grow well with certain bushes or trees.
Sure.
And they work together symbiotically.
Yes, agroforestry.
That's
agroforestry is
yeah.
the term. And sure, it's another approach to food production that employs the growth of perennial plants. Perennials like trees and shrubs. Perennial plants means that they will live many years or even decades on the land, and because of that, definitely they bring benefits to soil biology. And so if we can maybe spare trees on a forest lot where we plan to grow corn, why not planting the corn in alleys between rows of trees? Okay, this is a way also to increase the diversity of the farm. Diversity of the farm that becomes also amicable to pollinators, becomes amicable to beneficial insect species. So what scientists have been demonstrating is that if I have a biologically diverse farm, and this biologically diverse farm is managed in a way to improve soil health, the soil microbes and fungi will become also suppressive of pathogens, microbes and fungi that could cause problems, disease to cultivated crops. So this is also another
symbiosis.
Yeah, another benefit, you know, of trying to employ soil health on a modern farm.
How clever.
Yes.
It's all there.
It's all there, and it has been basically adapting through a long time, as we have been observing happening in natural systems. So why not learning from nature valuable information that can make our farm more sustainable, that can make our farm becoming weaned from the use of chemical fertilizers or other products of synthesis like pesticides.
Actually working with the soil.
And absolutely, this kind of agriculture works with the soil.
Huh? What fun! What fun! And sometimes you get some indicators that maybe the land has certain characteristics when you look at some of the weeds and things.
Oh, absolutely. The farmers wage war against weeds, right?
Yes.
The same connotation, the word weed is an unwanted plant. And so for a very long time, we have become accustomed to spray herbicides, even in our home garden, you know. That Roundup is the quickest tool, the quickest fix to get rid of the weed. But somebody like this Hanfried Pfeiffer um, wrote a little booklet in the 1950s, early 1960s, that is basically telling us that weeds can be very good, reliable indicators of soil health, of what the soil is all about, why dandelion is growing in that spot. Why, for example, lamb's quarter is growing or pigweed is growing on that spot of the field.
Or chamomile.
Or chamomile, exactly.
We recently saw a farm that had a lot of chamomile.
Exactly.
And what was it? It was compacted
Yeah,
soil?
chamomile, according to what Pfeiffer writes, has to do with soil compaction. So maybe, if you remember, is where maybe we saw along the path where the machinery was passing by. And so imagine, you know, a heavy tractor compacting the soil, then squeezing along that track any form of vegetation. And so that soil eventually, when the snow melts or the rain comes, becomes also more eroded. So without that topsoil or minimum topsoil, then the soil becomes compacted. And so it may form a crust. But there are some weeds, and chamomile, Pfeiffer writes, that like that kind of environment. So that can be an indication of what's going on. Maybe the soil is too acidic, maybe the soil is too alkaline, maybe the soil is deprived of calcium or other bases. Certain plants like or dislike that. So just by walking the fields and observing a little more about what's going on, especially on the edges, and we can better understand. Another characteristic that I wanted to mention in this conversation of ours is the texture, okay? We talked about the three soil particles, and their combination forms a texture that can be named according to the classification that soil scientists made in that soil triangle that you're going to see in this program. Here, I have put maybe 10 minutes ago a little sample of my pulverized garden soil in this vial and mixed it with water. So as you can see, all the heavy particles, particularly the sand, has been depositing at the bottom of the vial.
Settling down.
The water, as you can see, is still murky. So up here I may have still silt and clay.
But it's more clear towards the top.
Absolutely. So that is indicating that also the silt is beginning to settle. So pretty much I would say around here, the demarcation line between darker water and lighter water. So if I get a measurement that is, you know, the percentage of the three components, okay, all I need in this little column is just a ruler. So I can measure, for example, the height of the bottom part that would give me the sand. I measure here 2.5 millimeters, let's say 25 millimeters. If I divide that value by the height of the whole column, which is 75.
And you got 25, well you got, yeah, okay, you got
Okay.
30% already.
Exactly. So that would be
30%
the
for the bottom.
percentage of sand. So you see the 30%. Now follow that line, 30% all the way up to the clay. Okay?
Okay,
All right?
yes.
And then on the right side you have the percent silt. So I could measure, let's say, the silt. The silt here I have about 18 millimeters. So 18 divided by the whole, which is 75,
Five.
would give me the percent of silt. So from that triangle now, whatever percentage, let's say 12%, 15% silt, draw the line from the side where I have silt all the way down toward the sand.
Oh, I
Okay.
see what you're doing.
Do the same for the sand, and then from the sand draw the line toward, sorry, for the clay, so draw the line from the clay all the way to the sand, and the three lines now intersect in a point.
Converge.
So that point in that sector of the triangle gives me the texture of the triangle. You can go also online, and if you do a Google search for soil texture, you may find a recent website of the USDA and RCS that basically has produced an online calculator. So you plug in that calculator 2 of the 3 percentages, and that calculator will give you the texture. That texture gives you
Because
a very
it always has 3 components.
3 components, absolutely. But that texture is a very important physical characteristic, because that texture tells you how water permeable or impermeable your soil is. That texture has implications for the density of the soil. That texture has implications for the porosity of the soil. So in my pads here, I have micro voids, micropores. Those micropores, believe it or not, contain or should have in a good healthy soil, should be split. 25% containing moisture, containing water, 25% containing air. Okay? So that air and water are the ingredients to promote and to invite soil living organisms to live and thrive. And those soil living organisms are basically facilitating the digestion of all the organic matter, all the crop residues that will become part of that cycle, as I was mentioning in my quote. Henry David Thoreau, by the way.
There it is.
Okay, is the author of that quote. Now it came back to my mind.
Naturally.
So this idea of soil health, very, very important. But to make it happen, number 1, like we said, limit soil tillage. Employ a system of crop rotations. And within this system of crop rotation, especially during the off season, you should have your soil covered with cover crops. Okay? This kind of triad of agronomic practices over the years will benefit the soil tremendously, that when you go around and you walk on it and you squirt a little bit of hydrogen peroxide, you will have a lot of bubbles indicating all those aerobic bacteria doing their job.
You can look at what's growing.
Absolutely.
What's not growing.
You can look at what's growing or what's not growing, but mainly what's growing.
Yes.
Because
yes.
what's growing, will tell you what kind of chemistry or physics you have in that soil.
Yes, yes. And again, I'm going to be showing some pictures from Polyphasis, because Joe Salatin does incorporate all of what Dr. Bruno has talked about today. So thank you for watching Backyard Wellness. And if you have any questions at all, you want to know more about these things, please contact the station at TCC TV 18 at 715-538-2311. And contact us. I hope we can answer your questions. Thank you.